Now, as we have seen that after setting up the link and checking the test tone, we can transmit audios, two audio, video simultaneously, or two audios, data simultaneously, which makes it a frequency division multiplexed link or a FDM link. Now we'll try to transfer few waveforms through satellite link. Now I've connected a function generator directly to a DSO and I'm seeing around a 1 kilohertz of waveform. Now I can feed this waveform. Instead of putting a camera, we are transmitting this through video channel and using another BNC to BNC. Now as you can see, this waveform, though little distorted, has passed through the video amplifier. Though through video amplifier the colored picture comes crystal clear. Similarly, we can transmit this waveform through the audio channels. We'll select this as mic so that no signal is internally selected, and we'll put it at say audio 1. Now as you can see, this is audio 1. Little distortion because this goes through the delay channel where it converted from analog to digital and again passed through a F4M and then back to digital. Now if I do this delay thing, you can see a little change takes place in the audio. Now the same output can be viewed at the satellite end. Now this is audio 1 at the satellite end. Connections similar to receiver are given at the satellite end. Now as you can see, passing from transmitter to satellite, it is pure. But once it transfers from satellite and converted through circuit, passed through number of circuits, the waveform is little disturbed. Similarly, we can view this signal at audio 2 at satellite end. And the same can be viewed at receiver also. So we can transmit few function generator waveforms through these links, and because these are low frequency links, so they will not support more than 10-15 kilohertz audio 1, audio 2, whereas video link will support up till 1 to 2 megahertz. Now similarly, we can transmit some data waveforms. Now for data, we'll select the switch data in transmitter, receiver, as well as at the satellite end, and ensure that the enable switch is off at the transmitter, as well as there is an enable which is basically a telecommand at the satellite end. These two should be switched off, and we will transfer a TTL from the function generator, and now the same output can be viewed at the satellite end also. This is the data output at satellite end. You can always notice that at the satellite end the waveforms are always pure as compared to at the receiver end. Now we know that we can transmit two audios or two low frequency signals as well as one digital or a high bandwidth signal. We can also transmit a telecommand telemetry signal. Now in the satellite end, as you can see, there is a telecommand signal. Now this is basically a telecommand signal. what you see here. Now pressing the enable will switch on the RC oscillator, and these are the address bits. You can see the same on the DSO also, and these are the data bits. So it's a kind of a big frame which you are able to see on a DSO at the data out at the transmitter end. Now if we select say 00, if we select say 1100, then we have to select the same 1100, and you will see a valid LED corresponding to enable glows at the satellite end. And similarly, if we select the same at the back of the satellite end, the valid LED glows at the satellite end also. So this address, same address, ensures that the data is now able to be transmitted through satellite and back to the receiver. Now as you can see, we have selected all the data bits 4, and you can see the corresponding data LED glows at the receiver as well as at the satellite end. And if I toggle it, you can see that the change is inevitable, is visible as at the receiver as well as at the satellite end. So this is how the telecommand is transferred from the satellite, from the transmitter to the satellite, and then to the receiver. Now I'll switch off this enable at the transmitter end and switch on the enable at the satellite end and select some different address, this time 0011, and select the same at the receiver end. Now as you can see, the valid LED is glowing, and if I toggle, you can see the data change at the receiver end. So basically the idea of telecommand is to control the satellites, to deploy the solar panels or switch on the TWTs, and the feedback can be viewed at the receiver end. And similarly, the telemetry is basically the IOs of the satellite, like temperature, voltages, etc., battery backup, which can be viewed at the receiver end. So we can transmit an entire frame from transmitter to the satellite, and we can view the same at the receiver end also. And you can see we are able to receive the same frame. And similarly, we can transmit a PC data. The way we transmitted a square wave or a telemetry signal, we can use these RS-232 ports and transmit a PC data from transmitter to receiver and to satellite.